By the mid-1800s, the industrial age was roaring with confidence. We had machines that could repeat movements with incredible precision. Factories were humming along, all using the same measurements. It was a world of standards, a world where order had replaced chaos. To the engineers of the time, it felt like they had conquered all the big challenges. Industry seemed well complete. But just beneath this shiny surface of order, a massive problem was brewing. It wasn't about calculations or theories. It was about power, real, physical power, the kind that slammed into metal inside foundries and workshops every single day. The kind of power that destroyed just as often as it created. Before a man named James Nasmyth came along, industrial force was like a wild animal. You could unleash it, but you could never truly command it. Imagine trying to shape a massive piece of iron. The only way to do it was with impact. A giant hammer would rise and fall, but its accuracy depended entirely on the skill of the person wielding it. It was guided by experience, by a judgment honed over years of backbreaking labor, not by a system that could be repeated perfectly every time. Every single strike was a gamble on timing, on strength, and on sheer endurance. Think about it. As the day wore on, fatigue would set in, and accuracy would suffer. Muscle memory was the only guide, not precise measurement. And these tiny inconsistencies, one after another, would add up until they led to catastrophic failures. For a while, this delicate balance worked, as long as the machines and the parts they were making remained relatively small. But the Industrial Revolution had no intention of staying small. Everything started getting bigger. Steam engines grew more powerful, their components more massive. Ships swelled in size and weight, demanding parts that could withstand immense pressure. Railways began stretching across continents, needing axles and shafts capable of bearing forces that had never been seen before. The pace of industry was outstripping the limits of the human body. So, how did workshops respond? The only way they knew how. They just added more force. Hammers got heavier. The blows got louder. The entire sound of industry became harsher, more violent, and a lot more dangerous. But simply adding more brute force didn't solve the problem. In fact, it just magnified every error. A heavier hammer didn't guarantee a better result. It just raised the stakes. It made every single mistake far more costly. A single uncontrolled blow could shatter a huge piece of iron in an instant. One misjudged strike could wipe out weeks of hard work. The material itself wasn't the problem. The iron wasn't failing. The method was. Factories had run headfirst into a contradiction they couldn't ignore anymore. They could generate power far beyond human limits, but they were still depending on human muscle and judgment to control it. Industry had figured out how to measure things precisely. It had learned how to create and follow standards, but it had not yet learned how to discipline its own strength. This is the world James Nasmyth stepped into. He wasn't some inventor just chasing the next new thing. He was a practical engineer who saw the same failures happening over and over again. Everywhere he looked, he saw metal cracking, not because it was weak, but because the force applied to it was uneven and uncontrolled. He saw expensive forgings failing, not from a lack of strength in the material, but from a total lack of control in the process. Nasmyth had a crucial insight. He realized that power itself wasn't the enemy. Uncontrolled power was force doesn't have a memory. It doesn't follow a system. It answers only to gravity, to chance, and to the limits of human endurance. He understood that just as early machines needed a kind of memory to repeat movements accurately, force now needed a structure, a system, to become reliable. Without this control, power was on the verge of becoming the biggest obstacle to progress. Not because there wasn't enough of it, but because it was completely unpredictable. Industry was standing at another invisible turning point. It didn't need more raw strength. It needed strength that could be trusted. And in the world of engineering, trust is something that can only be born from one thing: control. Before Nasmyth, industry was a constant battle against force. Imagine blacksmiths, muscles straining, trying to shape massive pieces of iron. Their power was limited by their own bodies, their success dependent on instinct and a bit of luck. The bigger the piece of metal, the bigger the problem. Force was a wild, unpredictable beast. You could unleash it, but you couldn't truly command it. Big projects were big risks. How do you build a massive engine part or a giant iron beam for a bridge when a single misplaced blow could ruin everything? Industry was hitting a wall made of its own limitations. Then came James Nasmyth. He wasn't a showman or a titan of industry seeking fame. He was an engineer. And he looked at this challenge not by asking how can we hit things harder, but by asking how can we hit things smarter. He didn't try to defeat force, he decided to tame it. He reorganized it. This is where the steam hammer enters the story, and it's a revolutionary device, but not for the reason you might think. Its genius wasn't that it could produce more strength than anything before it, although it could. The revolution was that it made strength measurable, obedient, and predictable. Here's how it worked. Steam, a reliable and consistent power source, would lift a massive hammerhead. Gravity, an unwavering natural law, would bring it down. The magic was in the control. The height of the lift determined the exact amount of energy that would be released. The drop controlled the impact perfectly. For the very first time in history, force could be calculated before it was even applied. Think about that for a second. This single change altered everything. Suddenly, a hammer weighing several tons could strike with the most extraordinary delicacy. It could tap a piece of metal as gently as you might tap an eggshell. Or it could deliver a blow of immense earth-shaking force with absolute intention. Strength became adjustable. It became predictable. It became repeatable. Force was no longer a matter of guesswork. It was commanded. The machine didn't rely on tired muscles or fallible human instinct. It followed a system. It obeyed a law. And when power became this disciplined, metal itself started to respond differently. The things people made with it, the forgings, became uniform and consistent. The rate of failures plummeted. The risky improvisation of the old workshops gave way to meticulous planning. This newfound control unlocked a new era of engineering. Engineers no longer had to fear designing large components. In fact, they started designing specifically for them. Factories could scale up their operations without multiplying their risks. Structures could grow taller and stronger without inviting catastrophic collapse. Power could be expanded without descending into chaos. The steam hammer did so much more than just shape iron. It reshaped confidence. Before Nasmyth, power was the master of the process. It dictated what was possible and what was not. After Nasmyth, power became the servant. It did what it was told. This transformation didn't arrive with a giant celebration or a parade. It happened quietly. It was embedded into daily practice, into the new expectations of what was possible, and into a growing sense of trust between humans and their machines. It was like industry had crossed an invisible boundary. First, machines had learned to remember, with things like the Jacquard loom. Then, the world had learned to agree on standards. And now, with the steam hammer, power itself had learned to obey. The legacy of this idea is all around us today. Every modern forging press, every controlled impact system, every machine that delivers immense force with pinpoint precision carries this fundamental principle within it. The principle that strength must follow intention, that raw force must submit to design. James Nasmyth didn't build monuments to himself. He didn't seek to rule over industry. His achievement was more profound. He imposed discipline on power itself. And once power became predictable, industry could finally trust its own creations. So, the next time you see a skyscraper, a massive container ship, or a powerful jet engine, remember that the modern world is not built on strength alone. It is built on controlled strength. And every time an immense force is released with restraint, with precision, and with purpose, the legacy of James Nasmyth still falls upon the world.